It is our first lecture of this week, students. Listen attentively of subject Bayesian analysis. Here I will explain an example. The statement of example. Suppose that a certain type of atomic particles is passed through a container of water. The horizontal deflection of the particle as measured in appropriate units has a uniform distribution on the interval θ1 and θ2, where θ1 and θ2 are unknown. Suppose also that the statistician wishes to select a bivariate Pareto distribution to represent the prior distribution of θ1 and θ2, and that he expects that the length of θ2 minus θ1 of the interval to be about 2.5 units. If theta less than minus 0.4, θ1 is less than minus 0.4 and θ2 is greater than 0.1, and the horizontal deflection y1 and y2 of two particles are observed with condition that y1 is less than y2, it follows that θ1 less than y1 and θ2 is less than y2 is less than θ2. Then determine the prior distribution. Suppose further that the deflection of 5 particles are observed as minus 0.27, minus 0.45, minus 0.36, minus 0.12 and 0.47. Also determine the posterior distribution of θ2 and θ1 and θ2, the expected posterior length of θ1 and θ2, and give for the given 5 observation. It is a problem of bivariate distributions. The solution is given here. The bivariate Pareto distribution of θ1 and θ2 is given as b into b plus 1 into a2 minus a1 raised to power beta 2 divided by θ2 minus θ1 raised to power b plus 2, where θ1 is less than a1 and θ2 is greater than a2 and b is greater than 0. We know that expected value of θ1 is equal to b into a1 minus a2 divided by b1 minus 1, and expected value of θ2 is equal to a2 into b1 b minus a1 in divided by b minus 1. Now the expected value of θ2 minus θ1, डिफरेंस ले लें ऊपर दोनों वैल्यूज़ का, इसे सिंप्लीफाई कर लें. आफ्टर मेकिंग सर्टन सिंप्लीफिकेशन which is given here, we obtain a2 minus a1 into b plus 1 divided by b minus 1. As expected value of θ2 minus θ1 is equal to 2.5. I think it is given in the statement of the question here. The θ2 minus θ1, the interval to be about 0.25 2.5 unit. It is given in the statement of the question. Now down the slide. Therefore, as expected value of θ2 minus θ1 is equal to 2.5, θ1 is less than minus 0.4, therefore a1 is equal to minus 0.4, θ2 is greater than 0.2, so a2 is equal to 0.1. Down the slide, replacing the respective values in this equation, expected value of θ2 minus θ1 is equal to this, therefore this is equal to a2 minus a1 into b plus 1 divided by b minus 1 is equal to 2.5. Please down the slide. Now replacing the values of a2 and a1. Here we have, after few simplification, we obtain b is equal to 1.5. Now hyperparameters. So hyperparameters a1 is equal to minus 0.4, a2 is equal to 0.1, and b is equal to 1.5, which we have obtained in as above. Therefore, p theta 1 theta 2 is equal to by replacing the values in this equation, this one, bivariate Pareto distribution. After replacing the respective values in this equation, we obtained this one, that is p theta 1 theta 2 is equal to 1.3258 into theta 2 minus theta 1 raised to power minus 3.5. डिनोमिनेटर को ऊपर ले जाएं तो ये नेगेटिव साइन आ जाएगा साथ इसके, और ये 1.5 प्लस 2 इज इक्वल टू 3.5 हो जाएगा. तो अल्फा इज इक्वल टू मिनिमम ऑफ a1, मिनिमम ऑफ x, मिनिमम ऑफ माइनस 0.4 जो a की वैल्यू होती है, और जो ऑब्जर्वेशंस हैं उनमें वो तमाम ऑब्जर्वेशंस लिख लें आप, जो ऊपर दे रखी हैं 5 वैल्यूज़. तो इनमें जो मिनिमम वैल्यू है वो अल्फ़ा की माइनस 0.45 आ जाएगा. सिमिलरली अल्फ़ा 2 मैक्सिमम ऑफ a2 एंड मैक्सिमम ऑफ x, उनमें जो मैक्सिमम है a1 और मैक्सिमम ऑफ x2, वो तमाम ऑब्जर्वेशंस 5 में से देख लें मैक्सिमम ऑफ x क्या है, और फिर इन सब में मैक्सिमम कितनी है a2 भी मिलाकर 0.45. देयरफॉर अल्फ़ा 2 इज इक्वल टू 0.45, बीटा इज इक्वल टू b प्लस n, 1.5 plus 5 for any number of observation is 5. Therefore, beta is equal to 6.5. Please down the slide. The posterior mean is equal to expected value of theta for given observation. Beta into alpha 1 minus alpha 2 divided by beta 1 minus 1. After replacing the values, we obtain minus 0.6173. Similarly, expected value of theta 2 for given observation x, beta into alpha 2 minus alpha 1 divided by beta minus 1. Replacing the values, we obtained 0.637. Expected posterior length. Now, expected posterior length is equal to expected value of theta 2 minus theta 1 is equal to expected value of theta 2 for given x minus expected value of theta 2 for given observation x. Replacing the values here, and we obtain 1.2543, which is the expected length. Expected posterior length of difference theta 2 minus theta 1. Now, this is the complete solution.